Yeah,
I think you're out of frame, so.
I am, yeah.
Have them running the calculators up, huh? Anybody else been having problems with anything Microsoft? Like Microsoft 360, Office 365 sucks lately. Can't save anything, like it's not just me? Okay. Switch over, like my desktop doesn't work, HP, Bill Gates is out. Fixing to get an Apple. I have to relearn. Does anybody use a Mac? No one uses Mac?
Yeah, Mac.
Do you think it's better than desktop, like PC?
I think it depends on what you're trying to do with it.
I'm just trying to work, like, mine's super slow, like, I don't care.
Get it back.
And just, when I hit click, I want it to do what I tell it to do immediately.
That could be your
I have
network.
problems with editing videos and outputs, and I just, whatever I say go, I want it to do what I tell it to.
That could be the network.
No, this is like on the computer. It was like the program, it's just like Microsoft. When I hit save, you should save, not this circle wheel stuff. That's in the computer, that's not the network. The network sucks too. So, now we're winding this down. I think we have one more quiz that's gonna be, assignment 2 is due Friday. Assignment 2 is due Friday. And I think we're gonna have a quiz next Friday that's gonna cover most of that material, but y'all, we're right here, we're right there, like, we're almost done.
Is the quiz going to be online?
Yes.
Okay, good.
Yes, the quiz will be online. How's my camera look, Caroline?
That's fine.
Getting most of it? All right, good. The quiz is gonna be online. We're winding it down. I'm likely to post a study guide for this exam, just because of the type of material that I've been given and kind of the haphazard way that I've distributed it. Probably gonna be a good bit of math on this one too. So I'll probably post some calculations and some practice problems that y'all can kind of get comfortable with doing those things.
For the final?
For the final,
Okay.
correct. What else? Anything else? I'm trying to think. I think that's it. All right. So we've been kind of talking about saving this water because we don't have enough of it. Well, we can't keep enough of it. We have plenty. We've had the same amount that we've had since the beginning of the formation of water. But there are certain ways that, that we can possibly hold on to our water in pools of whatnot so that we don't lose it to the atmosphere. And kind of one of those ways is going to be through wetlands. So wetlands they're very integral to our ecosystems and environments and how we live. Like, without them, we'd be screwed. So wetlands are important. I really like this quote from Aldo Leopold. Our goal is to try and get back to doing things for the right purpose and improve the integrity and the other things of our communities, right? We're all trying to get back to biodiversity, and we want our systems to start running better because we as humans mess things up. Whenever I put my hand in something, I typically make it worse. So this thing, wetlands kind of serve as that good thing that fixes all the bad stuff that humans do. And so over time, before agriculture really took its boom in the 50s, after everyone came back from World War II, agriculture started picking up after that because we have more people back in America. We're trying to feed our population. So Norman Borlaug comes along and everyone goes, yes, we need more food and we're going to take some of this land back, and we don't care about wetlands. We're going to do what we need to do in order to get the food that we need to get. And so, on top of that, because we have more people, we need some of this land also for houses. And so urban sprawling is a big deal, and we're still continuing to see that. So while our populations are increasing, this 9 billion people by 2050, we're taking some of our space and we're converting that into cities and places where houses can be built and whatnot. And then as we have more people, guess what? We need more roads and infrastructure. And if it happens to cut through this wetland, we'll just take the wetland out because we really need to get there instead of making this big circle around it. So those are some of the things that have led to this this need for kind of the Corps of Engineers to jump in and say, hey, wait a minute, we're messing this thing up. And we need to make sure that we don't mess it up too bad. We need to make sure that we don't mess it up too bad that we can't fix it. And so we need to start making sure that our wetlands are being preserved because of all these things. Rachel Carson, Silent Spring, all of that comes through. The EPA comes in and says, we agree, Corps of Engineers, you're in charge of this thing since you had such this great idea, because that's how things work. When you have the great idea, guess who's in charge of it? You. So over time, we slowly but surely decreased our losses in wetlands. We were losing, almost 2,000 square kilometers a year, and then now, I guess I found this figure in 2004, we were finally starting to increase. So we're offsetting some of this land that we lost in the 50s and the 70s and the 90s. And I'm pretty sure that this number has increased because we finally recognize that these things are super important to us. So wetlands are this ecotone. And so from that first slide, they're the things that kind of buffer against any of these problems. Like this is like the last line of defense for our ducks and our fish and our aquatic wildlife. I guess as being part of this wetlands thing, I did this 3-minute thesis where you had to give your whole entire research in 3 minutes. If y'all thought that 5-minute presentation was tough, imagine trying to condense a dissertation into 3. And so I kind of let out with it, picture this pristine little place, the cabin in the woods, the Facebook thing. If you had, here's a cabin in the woods, would you take $1 million to live here forever? Like, yeah, duh. I just need the $1 million. I'll build a bigger cabin. But like that type of thing, and it's the runoff and the pollution and all these things from these other industrialized activities and ag and all those other things that are threatening this ecosystem. So our wetlands are kind of the buffer strip or the buffer zone to kind of hold this stuff back and kind of clean and filter everything before it makes it into our waterways. So this is probably one of the most effective tools that you can use or implement in at least not decreasing our water quality. And I know y'all do a lot of wetlands and NRCS, like that's the go-to. It might take a little bit of time because those biogeochemical processes, but eventually it serves a huge benefit. So currently, they're only about 5% of the land. It's interesting to think that a third of all the plant species are contained within a wetland system. I didn't really think that that was the case. I only know like two personally for me, cattail and duckweed, because those are the two that I work with. But is anyone taking limnology next semester? Ask Isaac if you need to know anything about wetland and the plants that are growing there, because I got a feeling that's what limnology is going to be about. But like there are many different plants and they all serve a purpose. Man, they're home to our birds, because we're kind of safe from predators unless you got like alligators and stuff in there, because four-legged animals really can't swim that well. So it's kind of a safe place for them. And it's also a food source. So now, because we're trying to improve our homes and our food source, we're taking it away from them. So every one thing that we do one way, it has this negative action the other way. And as I've gotten older, I've come to find out that that's a life thing. That I'm going to have to give up something. Like I may want this, but there's an equal and opposite reaction on the other side. Like I don't get it both ways. I can't have my cake and eat it too. Like it's kind of like that thing. Do you want to be right or do you want to be happy? Both. Very rarely am I right and happy at the same time. So not only is it home to 50% of the birds, but 46% of the endangered species are in wetlands. And so we're talking like frogs and salamanders and turtles and all these other kind of aquatic biota that are kind of that live on that fringe that can't really live very far along without water. But need that sanctuary so that they can get back to their habitat kind of, I feel safe-ish, rather than humans coming in and taking my thing away. I can get away from the snake or whatever, those snakes can swim in the water. Some of these are going to be dependent upon different water sources, whether it's rainfall. Some of them can be supplied from groundwater. So if the water table is high enough or the soils are shallow enough that there's just a wetland there. Like no one even tried to do that, it just happened. How long that water is going to be there, but most importantly is that it's going to be this nutrients and organic matter that are going to kind of dictate what how our wetlands are characterized. So a couple of the things, and like this is probably an NRCS thing, there are like 3 criteria to be determined a wetland. And so one is going to be inundated with water for at least part of the year. And now when we say part of the year, that isn't like a puddle outside just because it rained 9 inches. Okay, like this has to be over like a large area that is just, you really can't drive a tractor through it during like the wet season, right? Hydric soils. Number one thing when they go to look for a wetland, they'll dig that big auger core and we'll look at this and then they'll go, you know what? That's a nasty looking stuff. That's probably a wetland because there's just no oxygen in there to continue that cycling. And then this hydrophytic plant life. Remember, 31% of our plant species are contained in wetlands. And so kind of one of the ways that you can determine if there's a wetland is you won't necessarily see like typical plant species, but you will see cattail. So like a ditch, where I see a lot of cattail at. And cattail are all over the place. So those are going to be kind of some key indicators. And so what they'll do is they'll either look for those indicators or they won't see anything and maybe they'll plant cattail to see if they survive. And cattail can survive not being in a wetland environment, they're going to need a good bit of water. So it's not necessarily that cattails are 100% if there's a cattail there, there's likely to be a wetland. Because I mean, I've seen cattail grow in some places that there just isn't much water. They are hardy and they're what you want to go after. They serve several benefits. So looking at the hydric soils, what do y'all think this smells like? That's right. Because there's no oxygen. And so this is when we talked about in the beginning of the class, like that oxygen and that infiltration. If there's no oxygen, then like that respiration and decomposition isn't happening very much. And so it just gets kind of like half decomposed. And I know y'all stepped in this stuff. Never been in a lake.
Is that why, I mean, there's some parts on our property where the soil just stinks.
Yep.
I mean, it just stinks.
There's no oxygen.
Huh.
Smells like eggs. Kind of.
Yeah.
Maybe. That's typically the one thing that I go for when I think about this type of soil. It'll smell like rotten eggs. It's got that sulfur kind of smell to it. It's got that low redox potential and that glade and mottled appearance. So that's NRCS. Like I finally got some soils brought in here. And then here we can see that it doesn't necessarily have to be completely saturated. So you might not be able to tell it here, but when I post the slides, you can see these kind of reddish iron. And so what color is rust? And so why does rust occur?
Oxygen.
Iron oxygen. So at some point in time, the water table dropped and there was a pocket of oxygen that caused these little oxidation. What about right here? This kind of chalky, salty. How did this get here? Think about from the first test.
Evaporation.
Sun evaporation.
What's it called? Salinization.
Salinization, right? So that water table came up as we had more rainfall in a different area that filled that groundwater. The water table then rose because of the rainfall. And with it, it brought some of those salts up. And then eventually, as the river started to subside, the water table dropped. So it's this fluctuation of this water table that is kind of dictating what our wetlands can be characterized as. So they're not always flooded, and we can see some of these as considered hydric soils compared to like, that's an absolute, no, that's hydric soil. Without a doubt, no question about it. Here, there might be a couple of other things going on, but that's not for this class. But typically, hydric soil. Supports this hydrophytic plant life. And so one of the interesting things about this root system that's kind of flooded all the time, rice have this as well, and cattail for sure, these little parenchyma tissue are able to transport oxygen to the root so that the root